Okay, good afternoon. How is everything going? So let's see you guys if already in. By the way, before I proceed to the lecture today, two announcements. The first announcement is the test. So as I already mentioned earlier, next Monday during the lecture class 1 to 3 p.m. will be your test, online test. Okay. So the covering chapter will be until the chapter of the content of this Monday, okay, which is including all the drift current density calculation, okay. So the whatever I teach today will not be covered. Okay, this is the first thing. Second thing, for the one group, I think one of your group missed the practical class, right? So if not mistaken, it's the Yong Chi Ye's group last time. I think it's during Tuesday. I think it's Haji or Tuesday, if not mistaken. One of the day, we didn't have any the practical class. Can we make the replacement class by next Tuesday? Is that okay?
I think okay, sir. No crash.
Oh, okay. So I will proceed with all the arrangement later, and I will send out the link to you.
Okay, all right. Thank you,
Okay.
sir.
All right. Thank you. Okay. So let's proceed to the lecture class today. So good luck with the Monday, the test. The test is quite easy. It's an open book test, so you can refer to any of your materials or whatsoever notes that you like. Okay. So all the formula, all the constant, please make sure you can check from the all the lecture notes that I given earlier. Okay. So let's start with the lectures today. So anyone can tell me what have we learned in the last Monday class? Anyone? Okay, maybe let's pick up some guy. Go can sing. What have we learned last Monday? Go can sing. Are you here? Go can sing. Yep. Career drift. Okay. What else? Your easy. What have we learned last week? Monday. What have we learned Monday during this Monday? Your friends mentioning about the career drift. What is the career drift? Your easy. Are you here? What have we learned during Monday? What can you remember? I supposed to ask in this way. What can you remember in our Monday class? Okay, you already give me the formula, which is good. J drift will be equals to the E mu n plus mu p multiplied by the E. So from here we know that we got a mu n and the mu p. These two are the mobility. Just imagine that this mobility is to describe how it moves. Okay, then we got the N and P, which is the electron concentration and the hole concentration. E will be the electric field that you apply onto it. Okay, then one more thing is the small e. But how are we going to get the electron concentration and the hole concentration? Yong Wing Liang, can you still remember? Yong Wing Liang, are you here? How can we get this N and this P? Based on what factor? Based on what factor we calculate this N and P? If let's say this is a compensated semiconductor. Yominian, still remember? You don't have to tell me the formula. You just tell me which factor will involve in that. That's it only. Yep. You will see whether it's ND more than NA or NA more than ND. Okay, these two things is the one who decided whether it's an N-type or a P-type. Like what Yominian told me here. ND more than NA will be the N-type. NA more than ND will be the P-type. Then we are going to use the formula to calculate. ND minus NA divided by 2 plus square root ND minus NA divided by 2 square plus NI square. Okay. Then if you want to calculate the PO, you need to use the NI square divided by NO. Okay, this is how we calculate it. So if you still remember last time I mentioned that there are two types of the movement that the electron will move. Which two types of the movement that will push the electron to move? Okay, let me pick some guy to answer this. Dan Xinchen, which two types of the movement that the electron move according to what? Dan Xinchen, are you here, Dan Xinchen? Okay. What are the two transport phenomena? Just now your friends saying that one is a drift. What about another one? Not exactly. Any other answer? There are two types of the phenomena that will make the electron move. One is a drift. Yep, another one is a diffusion. So Yan give a very good answer, and Dan Xinchen also provide a very good answer, which is the diffusion. But what are the differences? We know that drift is according to the electric field provided on that. What about the diffusion? Dan Xinchen, do you know this? What is a diffusion? Yep, high concentration to the low concentration. So very good. So today we are going to study about the diffusion, which is a high concentration to the low concentration. So in a semiconductor, when we are going to calculate the current density, it will involve the drift factor and the diffusion factor together. Drift factor, we already learned it. We learned it through this E mu N plus mu PP plus E. This is a drift factor. But what about diffusion factor? How are we going to calculate the diffusion factor? So in order for us to measure about the diffusion factor, we know that the diffusion factor is from the high concentration to low concentration, which means that we need to measure the distance from one point to another point. And then we will see how the concentration dropping. In the other word, we need to see the distance and the concentration also. So in this case, we are going to consider the differentiation of this. Okay, dn and ds. At the same time, there's one thing we need to multiply with a factor. We call it as a coefficient factor. Okay, so let's get back to the slide. See this. At this time, I already told you, diffusion is the process where the particle fall from the high concentration to a low concentration, and then it becomes like this. Okay, one formula. So this is the formula that we are going to use. Remember, just now I already told you that it's the changes of the concentration in between the distance. Then we need to multiply of the factor, dn factor, this factor you can think like that. How good it will move, how fast it will move. Okay, that's a rate. You can say it as a rate. cm square per second. From this thing, you can know that actually this is an area per second. How many area per second it will move. Okay, and then last but not least, you need to also multiply this electric charge. Okay, same like the last time that we did. We have to multiply this with the electric charge. So in this case, we also need to multiply with the electric charge. Okay, so this is the formula that we are going to use. Okay, but you can see that actually this one is for the N, for the electron. But what about the hole? If we are going to deal with the hole, we need to put a negative E and then dp, then this one is dp over ds. Because electron is moved against the electron direction. So that's why we need to put a negative factor over here. Okay, so just like this. This is the one. You can see that here's a negative. So this is how the hole moving, the changes of the hole in one distance. So if people ask you to calculate the diffusion density, then you need to consider the E dn ds minus E dp ds. But if people ask you to calculate the total current density, which is a J, then you need to consider the one from the drift, and then this one is from the diffusion. At this point, can you understand this? Everyone okay with this? Okay. Oh, if you think okay, then okay. Okay, good. Okay, let's try one example. Assume that in the N-type gallium arsenide semiconductor at T equals to 300K, then the electron concentration varies linearly from 1 times 10 to the power 18 to 7 times 10 to the power 17 over a distance of 0.1. Calculate the diffusion current density if the electron diffusion coefficient is dn equals to the 225 cm square over second. So let's see this. In one shot, since this thing is only provide the information of the one electron diffusion only. So that's why we only need to consider the electron diffusion density. Formula wise, J diff will be equals to the E dn over ds. E is a constant, 1.6 times 10 to the power negative 19, if not mistaken. 19 or negative 19, I will do it later. Then multiply by 2 to 5. And then multiply by 10 to the power 18 minus 10 to the power 7, 10 to the power 17 divided by 0.1. Okay, by considering all these factors, we can calculate the answer. Anyone can calculate me the answer for this case? Okay, let me check something. Okay, notice should be the lecture 2. I want to check the constant value again. Okay, so E is 10 to the power negative 19. Yeah, correct. Okay, all of you, please calculate me this answer. So you should get about 108. Do you get the same answer as me? My calculation here is 108. So this one should be A over cm squared current density. Okay, so this is how we deal with it. Very simple. Okay, then we also calculate something like the Einstein Relationship. Okay, so consider the non-uniformly doped semiconductor and assume there's no electrical connection, which means that, okay, there's no, you didn't plug in any electrical field on that only. So in this case, it can be proved that dn over mu n equals to kt over e, dp over mu p equals to kt over e. Then dn mu n equals to dp over mu p equals to kt over e. So let's see this. We can see that the mu n and the mu p actually is coming from the drift factor. Then the above one is the diffusion factor. So in this formula, you can see that we are trying to link the diffusion factor and the drift factor together. But somehow, in the Einstein relation, we proved that if we are going to use the dn over mu n equals to dp over mu p, it will be equals to the kt over e. Okay, so this is one formula to relate everything. So let's see. Imagine if at this case, okay, given the mobility is 1000 at t equal to 300k, and then calculate the diffusion coefficient. Okay, so this one very simple. All you need to do is, we know that dn over mu n so kt over e. So this one will be 0.0259 eV divided by e dn over mu n, which is 1000. So this one e, you can remove it. dn equals to 0.0259 multiplied by 1000. So by having this 1, 2, 3, you know that this is 225.9. Okay, very simple only. So the most important one is the next one, Hall effect. So just now, we are going to measure everything if we know all the concentration or whatsoever, all these things. But in the real world, we need a machine to measure whether the semiconductor is the p-type or n-type. If it's the p-type or the n-type, then what is the concentration of an n-type? No concentration. And then what is the mobility? So there's one thing we call as a Hall machine. It can help us to calculate this NO concentration and the mobility concentration. So by having this machine, it can help us to distinguish whether it's a p-type or the n-type. Then it can help us to determine the majority concentration. And then we can also measure the mobility. Okay, so by having this machine, actually it connects something in this way. Let's see. Okay, at first you provide the voltage here. Okay, Vx. Then this will be having the current here, Ix. Then this thing will be a semiconductor, assume, okay? And then you are having the depth, width, and the length. Then on the other side, you provide the Hall voltage, and then you also provide the magnetic force here. So if you are providing the Hall voltage, you are going to apply for the electric field in this way, this direction. By having all these factors, we are going to calculate what is the concentration and whatsoever thing. But how are we going to measure everything? So there are basically three major formulas you need to remember if you are going to apply this thing. Because we are going to use all the dimensional factor to calculate everything that we want. So first thing you need to remember, in order to determine whether the semiconductor is a p-type or n-type, at first we need to see what's the Hall voltage. Okay, Hall voltage is the one given here. This was a Hall voltage. So if this Hall voltage is a positive, then this is the p-type semiconductor. If this is the negative, this will be the n-type semiconductor. But how are we going to calculate this Hall voltage? You can use this formula. EH will be equals to the EH multiplied by W, which is the Hall electric field multiplied by the width. If you go back to the slide just now, we know that the Hall voltage is here, and the width is here. We just need to use these two factors to calculate this thing. Okay, so second formula, we are going to equal this VH will be equals to the Ix, Vz, E, P, and D. Assume that this is a p-type. Then we will see each element one by one. So just now I mentioned that in the Hall voltage machine, I will provide the Vx, right? Originally, go back to here. If Vx is here, so there must be the Ix. So to calculate the Hall voltage, we can use this formula. Ix is here. Vz is the magnetic force over here. E is the constant value, which will be equal to the 1.6 times 10 to the power negative 9. P, Hall concentration. D is the depth, which is regarding to this D, means the thickness of the box, these boxes. Okay, imagine if we know the VH, if we know the Ix, we know all these things, then we can simply calculate this P out by considering the dimensional factor and the VH and the Is that we can provide it. And this thing we can also calculate it based on the machine that we have. This thing is a constant only, so by having all these things, we can easily calculate the Hall concentration. So you might be wondering, what about the n-type semiconductor? So for the n-type semiconductor, you can also using the same formula. At first, determine where the VH is a negative. If this is a negative, we know that this is an n-type semiconductor. Then your VH will be equal to the negative Ix, Vz, E, N, and D. Why is there a negative value? Because your VH is already a negative value. So you need to remove the negative element together. So this thing provided, and provided. You can see all these four elements are originally the same as this formula. Just that P we change to N only. So by having all these things, we can know whether your P and your N, what is the value by using these two formula. Okay, so after getting this, we can also calculate the mobility. Okay, after we know that the P and the N, we are going to start to calculate the mobility. In order for us to calculate the mobility, we need to use this formula. Ix, L, E, P, Vx, W, and D. Okay, let's compare to the picture side by side. Okay, Is provided. L is the length over here. E is a constant. P, we have already calculated the P based on the formula above, which is this one. Vx we provide, no problem. W is the width of these boxes, no problem. We can get it. D is the thickness. Okay, so basically we can measure everything based on what we have over here. Very simple only. And we also do the same thing to the mu n. IS, L, E, P, sorry, this time it should be N. VX, W, and D. Everything are still the same except this N we get from the above one. Okay, so basically we have to know two formula, then we can simply solve all the things that we want. And one thing you have to know is when we are going to apply these two formula, this and this, we are going to apply in the SI unit. What does it mean? So let's see one example in order to get you familiar with that. So let's see. Okay, remove all these things. Too many things. Okay. Normally, the question will ask you, calculate the major carrier concentration and the mobility, considering all the factor over here. Okay. L, 10 negative 1 cm. W, 10 negative 2 cm. D, 10 negative 3 cm. IX, 1.0 MA. Vx, 12.5 V. Bz, okay, Bz we normally will use the Tesla value, 10 times 5 times 10 to the power negative 2, and Vh will be equals to negative 6.25 MV. Okay, first thing we have to check is the Vh. Is that positive or negative? So the question is already given. Vh, we know that this one is a negative value. So we know that this thing is the N-type semiconductor. N-type. So in order for us to calculate the whole the electron concentration, we need to use the relevant formula to deal with it. So just now we are using this VH, IX, EZ, E, and D, negative. And then we rearrange everything. Okay, so N put the above, VH put the below. N will be IX, EZ, E, VH, and then D, negative value. Okay, we are going to use this formula. Then we are going to put in everything. Let's see. Just now I mentioned that we are going to change everything into the SI unit. So, to do this, negative IX. IX is 1.0 MA. So this is 1 times 10 to the power negative 3 or 3. Okay. Should we come back to here? Negative 3. Okay. Sometimes I also blur a bit. And then the B side. B side is 5 times 10 to the power negative 2. Then we divide it. Divide 1.6 times 10 to the power negative 19. VH, negative 6.25 times 10 to the power negative 3. And then the D. D is 10 times 10 to the power negative 3. 10 to the power negative 3 multiplied by 10 to the power negative 2 because it's in cm. Okay, so we need to convert back everything into the SI unit. So by having put everything in here, you can see that all the things is already here. 10 to the power negative 3, 5 times 10 to the power negative 2, 1.6 times 10 to the power negative 19, 10 to the power negative 5, which is equal to the D, and then this one is 6.25. So by calculating everything out, you will get the value of 5 times 10 to the power 21 liter minus cube. Then you only convert it back to the cm. Okay, 15 cm minus cube. So this one, we already know what is the concentration of the electron. But what about the mobility? So get back to the slide just now. For us to calculate the mobility, mu p will mu n, space mu n. Ix, L, E, N, Vx, W, D. Okay, let's see. Okay, this thing I move. So this thing I move up a bit. Okay, so let's write Ix 1 times 10 to the power negative 3. L is what? L is 1 times 10 to the power negative 2. D, okay, 1.6 times 10 to the power negative 19. And we use the SI unit one, 5 times 10 to the power 21. Vs, 12.5, which is this thing. Vs is this. W is this. Times negative 2 times 10 to the power negative 2. D, negative 3 times 10 to the power negative 2. Okay, so by considering every factor, eventually you will get the answer. The answer will look something like this, 0.1 meter. Okay, 0.10 meter square BOS. Okay, and then you can also further recalculate it into the cm square. Okay, so this one will be multiplied by 1, 2, 3, 4, 4, 0, 1, 2, 3, 4, 1000 cm square BOS. Okay, so basically we just need to use two formula, then convert everything into the SI unit, then we can calculate the thing out. Okay, maybe you try one example here. Okay, let's see this. This example. Calculate the IS and the VH on the p-type silicon, consider all these factors. Okay, you can try this. So let me write you the formula here. Since this one is the p-type, we can know that you don't have to bother the negative sign. E, P, and D. And then the mobility. Mobility is mu P, Ix, L, E, P, Vx, W, and D. Okay, do you get an answer? Anyone? Who hang down? Or you're still calculating? Okay, our friend who don't get the answer of Ix, which is equals to 2.048 times 10 to the power of -4. Do you guys get the same answer for the rest of you? And then the VH he get is equals to the 8. Okay, B. The rest of you? Lao Lộc Tinh, what about you? Okay. The remaining of you, if you have calculated the answer, just type on there. Okay. You didn't say the same thing. Okay, one little thing that you need to know is the mu p over here. You can see the mu p actually is in the form of the cm square over bx. Please convert back to the meter first before you proceed. Okay, So in this case, your BOP originally is 320. So you have to convert it back to the meter. Okay, so it should be divided by 0.032. Okay, after that you only proceed that. So your friend give us the answer. I believe it's the majority also getting the same answer, right? So what about the remaining of you? Do you get the same 2.048 and 8B? Okay, we still have 15 minutes left. Maybe you try another one more question. Then we can end the section for today. So let's see. So given the, let's say, Ix equals to, let's say, 2MA, and then the VH is 2.5V, then L 0.2, W 2cm, cm, D 8 times 10 to the power of -4 cm. Okay, then calculate the majority, carrier concentration, and the mobility. And okay, don't forget Vx, 10V, then your Bz, 5 times 10 to the power -2 Tesla. Okay, using all this info, try to get the majority, carrier concentration, and also the mobility. So formula is here. Sorry. So here for your reference. Okay. Okay, in this case, is this the P type or the N type? Okay, let me pick some guy. Brenda, this is P type or N type? Brenda, are you here, Brenda? She take vaccine? How come she's still here? She already took vaccine or she's taking vaccine? Okay, on mailing. Are you here on mailing? Okay, is this an N type or P type? Okay, so obviously this one is a P type because our VH is a positive value. So we can know this is a P type. But what about the majority concentration on mailing? What's the value that you get? Your IS given, BZ given, G constant, D also given, your VH also given. Okay. Okay, on mailing, after getting the answer, please let me know. Type the answer over here. Okay, on mailing, get the answer of 3/12. 5 times 10 to the power of 19. Then your mu P is 1000. Okay, the first one is in what? cm or m? Or mailing? In meter. This one? Also in meter. Okay, the remaining of you, do you get the same answer? Long Yao Ting, what about your answer? Long Yao Ding, are you here, Long Yao Ding? P, you get 17 for cm. Okay, the remaining of you, Ng Han Sam, what do you get? Same is for which one? Heading answer. What about Teo EC? Teo EC, are you here, Teo EC? Okay, still calculating. Yong Chie, what about you? Yes, Yong Chie, are you here, Yong Chie? Okay, the remaining of you, for those who have already calculated the answer, please type in the chat box so that I can see that. You have 19. Now Lục Trinh get the same answer. Long Yao Ding, I think you might want to calculate the answer again. Okay. Okay, so I assume that this one correct. I don't want to calculate again because it takes a lot of time to calculate. Okay, so far any question? If no question, I think that's all for today. So for the next week, next Monday, 1 to 3 p.m. will be a midterm test. So please get ready on that. And good luck for the test. Okay, so I think that's all for today. Have a nice day. Have a good weekend. You may leave the classroom right now. Thank you, everyone. Okay, thank you, everyone. So in Chang, I think you may be able to complete the answer again.